In this video, I'm going to demonstrate how to use the Select by Location functionality associated with ArcGIS. Select by Location is a very powerful tool that is part of many different types of spatial analysis. In this example, I'm going to show how we can use Select by Location to determine the area and number of agricultural districts in various towns in Oneida County. The two data sets that are shown right here are Ag-Onei 2010, which is the boundaries of agricultural districts. Those are special areas in which agricultural operations are favored in Oneida County, New York for the year 2010. The other data set is titled 065, which means Oneida County again in census code, MCD, which stands for Minor Civil Divisions, referring to town, village, and city boundaries, and the 00 refers to the year 2000. I can look around Oneida County a little bit in central New York by using the Identify tool, and I can click with the Identify tool and click in an empty looking town of Oneida County in the Adirondacks or on the edge of the Adirondacks called Forestport, which has no agricultural districts. They don't have any significant agriculture and haven't set aside or created any administrative support for agriculture up there. It's lots of trees. Likewise, the town of Florence has a very limited amount of agricultural enterprises up in the North Country. Conversely, the town of Marshall has a substantial amount of agricultural, and hence a lot of areas have been designated as agricultural districts. So what we're going to do is, first step I'll do in this one I think, is find out how many and how large are agricultural districts in the town of Deerfield. In order to do this, I'm specifying Deerfield as the target town out of this whole group of towns in Oneida County, so I in some way have to designate that the town of Deerfield is going to be the one that I'm going to be working with. I can do that by selecting the town of Deerfield. That can be done by using this button right here, which is a manual select, and then just clicking somewhere in the town of Deerfield, and it shows up with that bluish color that indicates town of Deerfield is selected. I could additionally enter the right-click and enter the attribute table of Oneida County towns and discover that the town of Deerfield is already selected, but I would not, in order to do it, by doing it this way, I don't actually have to know much about the geography of Oneida County. I can just look at the list of names here. For instance, if I want to find out where Vienna is, I click on the far left in the little selection box here and discover that Vienna is way over in this part of the county. Additionally, if I wanted to do manual selection, I could use another trick, which I'll just sneak in here for your amusement. I could right-click on the feature and ask for properties, again on the feature class, ask for properties and ask for labels, and tell it that I would like the labels to be shown and use the name of each of these towns as a label, and I'll make them maybe size 12, and I'll make them I always think that says unicorn, it says Unicode, and Batang, whatever that is, and I'll make them bold and underlined to make them viewable. We'll do more with symbology and cartography later, but now I'm able to easily identify where all the towns are in this particular area, a step in cartography. Why don't I go right ahead though, since I'm after Deerfield, and click on the town of Deerfield, and now town of Deerfield is selected. Where I can go with this next is to the selection menu and ask for Select by Location, and now I just need to fill out this dialog box. And it says I want to, or it should say I want to, what we're going to do is select features from the ag districts. So the first choice we make in this dialog box is what we want to pick from. we are going to use MCD, minor civil divisions, as what's called the source layer, and that means that that is what is going to be used to make the selections, not what's going to be selected from. And there's a checkbox here which is essential that says use the selected features, and there's one which we confirm is the town of Deerfield is selected, so I'll choose that. And what I'm going to want to do is select all of those agricultural districts that have their centroid within a particular town. So if I can expand on this a little bit, I can show you that in some cases an agricultural district actually crosses a town boundary. So the question would be, where does that ag district get counted? We can pick the center point or the balance point for this particular ag district, which is probably right about here. Actually, maybe it's here. And select that one specifically, rather than having it selected in both the town of Ava and the town of Western. So, I'm going to use centroids, and that number falls at the very bottom of this list. And there's a list of methods that can be used for select by location. That lies at the bottom. And I'm not going to apply a buffer or anything, so I'm just going to say OK. And shortly, when I zoom back out, I will be able to see the town of Deerfield and all of the agricultural districts that have their centroid within the town of Deerfield are now selected in that layer. And clearly, this agricultural district right here has its centroid just outside the town of Deerfield, so strictly by our rule, we're not going to count it. If we wanted to be very precise, we could cut and slice and dice up census blocks, but that's a little more sophisticated than I'm interested in showing today. So at this point, we have all of the agricultural districts in the town of Deerfield selected according to our definition of what in means. And now I can go and visit the attribute table of the census blocks and discover that there are 47 selected. And as I scroll down, I can see that well, they're all concentrated. There we are. All the ones that are have their centroid in the town of Deerfield are shown. So the first answer for today's exercise, 1/6 of your work actually, is that there's 47 ag districts. And I didn't mean to say census blocks, which I think I remember just saying. 47 agricultural districts in the town of Deerfield, separate districts. I can go ahead now and do a very slick little trick, and that is I can position my pointer on the heading of the column that's called area, which is the area in square meters of each agricultural district. And when I focus it there, I get this little black down arrow. I can then right click and say statistics. And what it will report for me shortly is that the sum of all the selected features in that column, 47 of them, have a sum total of, and I'll place my comma there and there, of 14,700,000 and some thousand square meters. So that's answer number 2. And that concludes the methodology for today. For your exercise, you'll go ahead and maybe repeat to check your method for Deerfield, so you can check your 17 million and your 47 total, and then go ahead and do the same operation for 2 other towns, Florence and Marshall, I believe I've asked for. And if you do that, you've gotten to a relatively potent level of geographic analysis.